You are live.
Are we live? Do we have any
We have 5
viewers
viewers.
yet? Let me just share my screen again. I want to use.
I believe that the next generation's degrees should be on video and audio setup for your laptop. Just that, just a whole degree, on that, and grammar, but like how to use Grammarly and Microsoft Editor. Just that, because what else more to life is that you know how to write something, and you know how to use your microphone and video.
No, I mean it's frightening sometimes. The inability to use the basics. I mean, people need to be taught to read and write and do basic arithmetic and then statistics and then critical thinking and then history and
I know how to multiplex a sine wave. Why? Why have I?
What is a sine wave?
It's an analog sampling rate for an amplitude and frequencies, because at some point
Does
someone
that go on
decides,
pizza?
no, it's not. It is. I think it's to do with like
it's how we're
electricity.
hearing each other right now because it's our mics are sampling and converting it to the proper frequency and sound engineers can adjust them.
I blame the British, because they were the first to industrialize, and if they had done it incorrectly, then we wouldn't have followed the Industrial Revolution, and then we wouldn't have all of these issues. So if you're listening, British people, please don't be so industrialist, and we can go back to ruralization.
Oh, but you see, the other thing that happened with education in the UK is literally, if you look back at the 19th century, they said, I'm reading history because there's a library with all of history in and they can sit and read it. Now there's no single library with all of history in it. And because it's getting added at a rate that we can't catch up with. So we need to teach children how to learn, not teach them facts. And I just see kids who can parrot facts instead of discover them and read something and decide whether it's valid or not by researching references and things like that. And unfortunately, it's not just kids, because it's a big part of problems that we face in the world at the moment.
You can always teach a kid critical thinking when you put a password protection on their device, and they have to try to circumvent it. And I've never seen my 5-year-old be able to hack a device so quickly like that.
Yeah.
Right motivation.
No, motivation's everything. Do we really only have Dav on board so far?
No, we've got 6 viewers.
Oh, okay, we have. So where did the numbers go?
It's just next to, it's top left.
Pamela, first of all, you look wonderful. And I look like an old leather shoe. It's great to see you again. And I hope the pandemic has been a meaningful and mindful reflection on life. And I miss seeing you at events and everything.
I miss events. I miss going out of the house occasionally.
Yep.
Thank you, Rory. That's very sweet.
Going to the store to buy something that you can't order is an whole adventure by itself nowadays.
The lady below me, here, is my code bestie Maya. She's a lovely lady. She's a good Android developer. Yeah, she's also going to speak at DevConf this year on Kotlin Compose. Hey,
Oh, wonderful.
Blessing.
We have somebody from Harrismith in the Free State. This is wonderful. So we can change the Josie to something else. I'm going to start collecting some ideas. But so regardless of whether our two entrants from last week, so for those of you who don't know, at the end of every session, I send out a link with a feedback form. And at the bottom of it, I invite you to enter yourself into the draw for a JetBrains voucher. Now, that is a voucher that basically gives you an annual subscription to one of the IDEs. So if it's depends on the IDE, obviously the price varies, but you don't get change. So, but it's basically worth somewhere between $150 and $250, which most people don't have just lying around. I don't know, maybe if they work for Microsoft, but so we've got two entrants, and what I do is I usually do a test spin. So Sia and Douglas, don't get too excited. This is not the end result. This is just a test spin so that you can see that it's not manipulated in any way. Nope, Douglas is not the winner yet. So now we do another spin, and this is the real one. Let's see if Douglas gets lucky.
I feel we should have like a terms and conditions saying that whatever Cornel says, it goes for rote. So yes.
Congratulations,
congratulations.
Yay.
I will be sending you the coupon because I have your email address, and I'll send out a tweet because you gave me your Twitter handle, and then people can come and line up to watch you use the full version. So congratulations. Now tonight, our topic is Kotlin Compose. I now just need to stop sharing and this one and start sharing my my presentation, which is over here. So what we are going to do is we're going to do two lightning talks. So that's basically about 15 to 20 minutes. And then we are going to have a panel discussion, and you can ask questions, because what we want to do is we want to talk about this thing and try and answer the questions, because if we have to cover everything there is to cover about it in a presentation, that presentation will be 2 or 3 hours long. So I want to put some ideas out there, get you excited about the possibilities, and give you the tools to discover. And then obviously also ask questions, and we will answer them to the best of our ability. Because Kotlin Compose as a framework is still relatively new. Jetpack Compose has been around for a bit longer, and it formed the basis for this. So I'm basically going to give you a short history and then an idea of what the possibilities might be, when it's a good idea to use it, and when not. And I might be wrong on that front. And then I'm going to show you some simple multi-platform example that I developed, and then I'm going to hand over to Maya to show us off some of her handiwork. So where does it come from? So Kotlin Compose framework is basically built on a few pre-existing technologies. The first one is Kotlin Multiplatform, which basically provides you the mechanism to write code that is common, and then to specify the pieces that are going to provide it in a platform-specific way in different libraries. So essentially, you have different source trees for the different libraries or the different targets, if you want to call it that. And because, for example, you can have code targeting the desktop written in JVM and targeting Android written in JVM, but you might split the libraries because you are doing different things, using different underlying APIs in specific cases. So Kotlin Multiplatform is the first building block, and it enables this. And it is it's been around for a while. I mean, I developed a library that I started sometime in, I think, early 2018, and published it on Kotlin Multiplatform. And I had no challenges at the time using multi-platform. So that's the first building block. The good news is there's actually a little tool that somebody built that allows you to generate a template multi-platform project. So you make some choices, and it'll generate a Gradle build file and the source tree that you can use. The next technology is something called Skia. That might be familiar if you know Flutter, because the Flutter framework is developed on top of Skia. So Skia is a cross-platform graphics library that does interesting things and is available on a range of platforms, and Flutter is built on top of that. Now, if you don't know what Flutter is a multi-platform UI framework developed by Google, and it uses the Dart language. Now, Google is a huge contributor to Kotlin Compose because I think they got to the realization that it's going to be easier in the long run to invest in Kotlin multi-platform than in building their own language and their own framework that has a very small user base, when there's already a pretty large user base using Kotlin on Android that can now easily move across to the other platforms, and they leverage this underlying investment that they've already made. So they're making huge progress because of this underlying investment, because essentially they're porting various elements of Flutter to the Kotlin Compose framework. And Kotlin Compose isn't brand new because it started life as Jetpack Compose, which was targeted at Android only. And changing your code from some of the Android specifics into away from Android specifics. I think the live data and those are the areas where you might have an impact. But for the rest, it won't be unfamiliar. Now, here's a timeline. Flutter was unveiled in 2015, which meant that they'd already done a lot of work to get Skia in place and everything. And Jetpack Compose for Android started in 2018. And Kotlin Compose's first commit was in September 2020. And then they released version 1.0.0 on the 1st of December 2021 and 1.0.1 on the 23rd. And that's been the official releases so far. Now, what can you target? So this is a pretty extensive list. So at the moment, Jetpack Compose for Android is mature, and Kotlin Compose for desktop has been released, and it's been pretty solid so far. And there's a lot of work ongoing to provide mechanisms to get feature parity between desktop and Android for certain aspects, so that you have an abstraction for navigation, for example, that you can use across both the platforms. Now, Kotlin Compose for web was announced, and as part of 1.0.0, they released what I'm calling web, the DOM version. In other words, it targets you creating an HTML page with those elements, and Compose capabilities provide for that. So you can create all the HTML tags and style them and things like that. But then they decided that they want to have a web version that provides you with the exact same experience in terms of coding and UI as you have on desktop and Android, which means that they're using the stuff from Flutter that targets the HTML canvas. So that is in development and is we'll have to see what it looks like. So there's going to be two ways to work with the web. The one is based on the DOM, and there's a group of people who are taking the original set of material design components built for the web component spec, and they're porting them to Kotlin Compose. So you'll basically be able to have that type of look and feel and build experience. And if you have an application that you developed, for example, with material on Angular, or one of the other frameworks using the material design components, you'll be able to port them onto the DOM version. Then, and I was lucky in predicting that it has to be coming, and it has arrived. So there's an alpha version of Kotlin Compose for iOS, and there's an alpha version of Kotlin Compose for macOS. Now, I don't have a Mac, so that I can't take those for a test drive or anything. I believe that Kotlin Compose for WASM is going to be available pretty soon after the new release of Kotlin WASM, because when they did the first version of Kotlin WASM, they used LLVM and the native. So they basically took the native code through LLVM into WASM, and the result wasn't great. And WASM didn't have garbage collection, which was problematic. So now the WASM spec is working flat out on getting garbage collection. There's a target that they're testing with. And the moment that that is mature, then we'll see a new Kotlin for WASM. And then the Compose for Web Canvas can basically be compiled to Kotlin for WASM, which will give you something that is close to native performance, but can run on any WASM target. And then there's Kotlin Compose for Embedded that I also predict will come, because there's a Flutter for Embedded, which targets some native platforms and WASM. So if you look at the capabilities of embedded chips nowadays, to have a WASM built in and a driver for the screen will give you a pretty decent embedded device. So that's what I think we'll be able to do. Now, this means that you can literally build a UI for any of these platforms. Now, obviously, there's like with anything, there's always a lowest common denominator problem, and there's a difference in look and feel and approach problem. So don't think that you're going to do one piece of code and it's just magically going to run everywhere and everybody's going to be happy. You are still going to have to do work to address the platform specific stuff. But you are going to be able to take a large chunk of your code and organize it in a way that core state management and interaction with the backend is in one place, and that you then have platform-specific divergence to address specific features in the platform-specific part of your project. So that is a quick run through. Now I'm going to show you a demo app that I did. And it originated, I've got a little project I built, which is a DSL for creating a state machine. And then I thought, what's an interesting state machine? So I took one that's a traffic intersection. So basically, now you'll ask, why is there 3 lights? So I want to make it difficult. So I want to show that I can have a traffic intersection with 2 lights and with 3 lights. Because sometimes you have a traffic intersection with 3 phases, and this emulates that. So what this does is if you start it, then it will run through the cycle, and you can force a switch, because typically it's something that the operators can do, or you can turn it into flashing red lights or whatever. So what you see here are screenshots of the Android version and the desktop version, and here are some screenshots of the web version. So I'm quickly going to show you each of these. I just need to find the right window to share. Let me just see. Okay, so I have an Android emulator that I started up. Where did it go now? Okay, here's my Android emulator. I just want to close everything behind it so that you don't get distracted. And I will see if I can find it in this list, and I think it's no, that's my code. Where is my application? Because no. You see, if I share my entire screen, then you are going to see a huge split screen of both my desktops, which is not what I want to show you. Oh, there it is. Okay. So, now, oh, that's not the one I wanted to show you. Sorry. This is getting tricky. I'm literally going to have to find a Windows machine just to do presentations. That's my code. Oh, that's that. I don't want to show you the entire screen. I don't want to show you that. It looks like it's not picking up this window. Let me just see if I do that. It might actually find the window then. Sorry about this. It shouldn't be taking this long. Come on. It's not that one either. It's not that one definitely. It's not that one. Nope. Unfortunately, it doesn't want to see the. Oh, wait, let me. What do you see now? Now you see two screens. Pamela, do you know if there's a way to cut the screen in half?
No, I'm sorry, I don't know.
Okay, so I don't know how bad this looks for the people out there. I should have actually just recorded this and played it, but there I'm turning it on. If you can see the emulator sitting here, so I've turned on. So imagine you get to the intersection and you turn it on, so everything's red, and now you say start. So now the first one goes green, and then after the timeout it'll go to amber, and then after the time it goes to red, and then after the time the other one starts green, and then amber, and then red, and then green, etc. And now I decide I need to quickly switch over, and when I click switch, then it basically goes to amber immediately, and then it runs the rest of the cycle. And I can stop the cycle, and then you'll see it didn't just go red, it went to amber and then red. And now I can say flash, and it's flashing the lights. Now each of those three lights are running their own state machine, and then there's a state machine for the intersection. So what I'm going to do
Cornel, we can't hear you. Your sound is gone. Sorry, Cornel, we still can't hear you.
is it better now?
It's very staticky.
And now
Still very staticky.
see, the moment another application does something, then it goes nuts.
It's a bit better now. It's still a little
Okay.
bit staticky, but it's okay. Okay-ish.
I'm trying to stop this. Okay. Let me run the desktop application. So desktop and run, and then I'll have something I can easily share. Okay, stop screen, let me share. And that's the one. Now, so now this is a desktop application. So it's basically a Java app running Compose, and I can do the same thing. I can turn it on and off. I can say start, and it'll run through the cycle. I can force it to switch quickly, and it'll keep doing that forever, because that's what traffic lights do. And then I can stop it, and I can say flash. And that's where the echo's from, and you can see they're flashing. If you look closely, you'll see they're not flashing exactly at the same time, because it's actually just events that are sent to state machines. That slight difference represents the timing of the underlying Kotlin coroutines running through its bit. So that's a simple version of the application. And now I'm going to show you the web version. I just need to get that running. Okay, I'm just going to do this so that it fits into a smaller screen, and then I'll share this with you. So it's now not that one, it's this one in Chrome. So you'll see it doesn't look exactly the same, because my CSS skills are relatively limited, but functionally, so the code that does the managing of the state machine is still the same code. The only thing that's different now is the code that's dealing with the actual user interface. And if you go dig in the project, then you'll see how that separation takes place. I'm going to stop it and show you that we can also flash the lights, and they're, once again, if you look closely, you'll see there's a slight, they're not all at exactly the same time, but there's a small difference, and that's because it's events that run through different coroutines. So that is the bits that I wanted to show you, and I'm going to share the link to the code, and then we can have a chat about it later on. But I want to hand over to Maya now, so that she can show you something that actually looks like it was done by somebody who does UI development. Thank you, Maya.
Hey Maya, you need to unmute.
Yes, I do. Sorry, very unprofessional of me. So I'm going to be talking to you about Compose animation. So Cornelius explained to us how Compose can run on different frameworks. And this is going to be a speed run. I'm going to give you a quick run through because it's a lightning talk. The subtitle for my talk is Animate All the Things, and I'll show you. So what I'm going to do is, who am I? First of all, I'm Maya, and there's my Twitter handle. You'll see here my Twitter handle. There, Twitter handle, and you can talk to me on Twitter if you need to ask me questions. So I'm going to give you a quick run through about how Compose works. Oops. Basically, Compose has nested functions. So you have functions calling each other, and the UI state comes in as a parameter into the function. Because in Compose, your state is immutable. You pass your state into the UI. You have a handler with which the events, if you click on a button, the events bubble back up, and then the events coming back up will change the state. What does this look like in the code? You've got a Kotlin function. It's got this @compose annotation, And then you pass in parameters, a modifier, some other state, and potentially some other block that can be a nested composable. So that's how the nested composable comes in. But what does this add composable do? It actually secretly puts this composer in as a parameter. So every single function, composable function, has the composer that comes in. And what does the composer do? Well, the composer has some data structures that saves the state. It can see when the state changes. It can see when it needs to recompose. So it can see that the state for this inside function has changed, and it will recall the inside function. Why am I telling you all of this? That's the way the animations will work. So you change the state, and you continually change the state, and then the composer will recompose the functions and actually change what's on your screen, and that's how the animations work. So the animation API sits on top of the Compose APIs, and there's a version that works on Android, but there's also a version that works on the desktop. And luckily, their syntax is the same. So just quickly running through the animation API, if you have no composable function and you want to make one appear, like a magician wants a bunny to appear, then you use this animated visibility. If you have one composable and another one, like you've got two cards, like a magician, you want to swap between, say, the heart card and the diamond card. So the heart card needs to disappear and the diamond card needs to appear. You can use the crossfade. There's animated content, which I'm not going to talk about today. And then there's a modifier which you can add to your composables, that if the content size of the modifier changes, it will animate the way the composable looks by animating the size change. So another way to do things is if you've got one thing that needs to change, so maybe you're just changing a color, there's a whole family of functions that you can call animate. I've put a star here, but it can be animate color as state, animate DP as state, animate float as state. And what this function does is it will store one value inside the state, and it knows it's got to change from green to red. It will calculate your interim values inside the state and emit the interim values from the state, and then your composables will recompose because the state has changed. But the state is all managed by this function. This one I'm going to skip over. The other one you maybe want to do is if you've got an animation, sometimes you want it to loop and continuously, like something that pulses or some animation that loops, and you can do that with an infinite transition. And then you can hook different parameters on this. You can hook colors on this or values on this, and this will start running when your composable gets composed. So let's just take a first example, animated visibility. So I've put GIFs here so that I don't need to have issues with demos. And what this does is there's a state, either show or hide. And depending on if the state is show or hide, then this bunny either appears or disappears. And you change the state by clicking the button. What does the code look like? It looks like this. So this rabbit composable is just a composable that pulls an image from your resources. So on Android, it would get that r.drawable.bunny or r.drawable.rabbit. On the desktop version, it would load a PNG or a JPEG file. And if you run this composable, it's going to draw the bunny. But if you wrap this in animated visibility and this show is a state variable, then depending on if this is true or false, it will animate the bunny appearing and disappearing. Let's take another example. So here I've got two cards. I've got a heart card or I've got cards of different suits. And if you click, it must change suit. And so here also you'll see I've set it to be really slow so you can see it change, but it's going to change the visuals and crossfade on the visuals from the one to the other. What does the code look like? It looks like this. So I've got this composable called red black card. You pass it as suit. Suit is just an enum, which could be hearts or diamonds or spades or whatever. And then we're saying that based on the suit, it must crossfade. So it will pass this value, and it's because there are two different values, say maybe a black card or a red card coming in here, then this crossfade composable will fade in the one, fade out the one, and fade in the other. I've got a cat walking here. Hang on. Go away, cat. So let's take another example. So here we have a composable that's got some content. It's got this bunny picture, it's got a title, and then it's got some other description. I'm going to put this cat on the floor. Hang on, cat. And if you click it, it switches between the short description and the long description. And you can see here, I've also set it to relatively long. The moment you click, then it changes size with animate content size. So let's look at this code. So this is just a text composable and the actual text inside it. So this is the text composable inside that card. If there's a state variable which says, is it expanded or isn't it expanded? And there's a click handler that changes this value. There's a long description and a short description. And as this changes, the size of this text is going to change. And a lot of the composables, they take modifiers. And in this particular case, the modifier, what this modifier does is it says, just animate the size when the size of the composable changes. So let's stop for a moment. The thing that's really interesting for me is that Compose is a declarative framework. So you don't actually need the imperative code to make it do the animations. You literally just say what you want. You say, I want a text field which could have either a long or a short description, and I want it to animate the size. And the whole of the API and the whole of the way that Compose works is in that declarative fashion. So the imperative code is much less. So now let's do something else. So this button, when you click it, it changes color. So it changes from either the primary to the secondary color. So this is the obligatory primary purple, and then that turquoise color, which is the secondary color. But what I want is when you click, I don't want the color to flash. I want the color to do a slow change. So you can see it clicks slowly, and then the color changes. Here I've also changed the text color, but the example I'm going to show you is just the color change as the button color change. And what we're going to use here is one of this family of functions that animate something as state. And in this case, it's the color that's going to be changing. So what does the code look like? Well, I've got a button color here, which is a color. This is the delegate, using a delegate in Kotlin. So it will get the value from this animate color as state. Now, animate color as state returns a state object which has a color inside it. And that state object, the composer knows about, and the color is going to be, the in-between steps are going to be managed by this method. And what we're saying is that if the show flag is true, we want it to be the secondary color. If the show flag is false, we want it to be the primary color. Now we're introducing a new thing here. This is the animation spec, and all of the animation functions, they don't need to take an animation spec, but you can actually change the way the animation works by adding this animation spec. In this case, I'm adding it, making it a tween. A tween will be a linear interpolation between two different values. In this case, it's going to go slowly over a duration of. So the value, the two colors, it's going to go linearly from the one to the other. And it's going to do that over a second. And then that's all of the animation code. All you need to do then is you've got your button and you just set the button color. And because this button color changes as the state changes, the composer knows that it needs to recompose this button because this button color has changed. So now let's take it a little bit further. So now here I've got some rainbow letters. And I'm going to show you the code if you have one letter and how you want to make it change slowly between the rainbow colors. And what I'm going to use is, again, the state and then also the keyframes. So my animation spec is infinite repeatable. We had that before because it's looping between the rainbow colors infinitely. And I'm going to use keyframes. So let's just look at this quickly. We have, remember, infinite transition. So this is a transition which will start running when the composable composes. We give it some other interval. And then what we're saying is from this transition, we want a color. So it needs to manage the color for me. We're saying it starts at the first value. So I have an array of colors here, a rainbow color array. The first value is red and the last value is purple. Now, if I didn't put the keyframes in, then it would just animate between red and purple like the button did. And it would skip over these in-between values. So what I'm doing here is my animation spec here is keyframes, and I'm setting timestamps. And I'm saying at each of these durations, I want the color to be the next color. Now this here, this pink part here, this is inside the keyframes, you can have the syntax with an infix operator, which will set up the table of keyframes for you. And so in this way, it's going to go from red to orange, orange to yellow, yellow to green, and so forth. And now there's this repeat mode, which means that when it gets to purple, it needs to start at red again. So it's going to loop back like that. And then this color gets set from state. And the only thing you have to do is for the text here, you just have to set the text color. And then it does that. Okay. So now let's take something a bit more complicated. I don't know how much time I've got. I think I'm okay. So now what I've built here is, it's a particle system. And particle systems are just an array of objects, and the objects know how to move and know how to draw themselves. So the particle part is the same as any particle system that you would find on the internet examples of, and they're just standard Kotlin objects. The piece of code I'm going to show you quickly is how you build a modifier so that you can add these particles to any composable. So what I'm doing is I've got a modifier. I'm making an extension function called confetti on it. If I use this composed, it's going to give me a composition. It's going to give me a compose function that gets called every single time this modifier gets used by any other composable. And then in here, I'm storing in the state so that the composer knows about it, this confetti state. Now, this confetti state is just an object that has an array of the particles, all the different particles inside, so that you can control them. Then I'm using a side effect called launched effect, and it's run off a flag so that if you click a button, then it could be either visible or invisible. And then what I'm doing here is I'm getting each frame that comes in, it's going to give me the amount of time that passed since the previous frame. So it's going to, this runs a coroutine, and in the coroutine, I'm actually getting a tick on every frame. And when I get the tick, I'll tell the compose state to tell the particles to move to the next spot so that they're actually moving in position. And then, don't worry about on size change, then modifiers have this method, draw behind. And what this will do is whatever you tell it to draw, so you get a canvas inside there, whatever you tell it to draw, it's going to draw behind what it would have drawn anyway. So if the composable has buttons or text or whatever it has in it, it's going to draw the particles behind whatever it has. And so it means now that here you can ask each of the particles to draw themselves on the screen. And because they're changing position, which you're driving from the tick, they'll look like they move. And how would you use it? You could use it on any composable. You just add .confetti. It's got more parameters here to set it up for different things. And then you'll see it draws the confetti. This one doesn't move, but it draws the confetti behind. So now let's see a demo of all of these things. So I've got a GIF here of everything, but I'm going to see if I can actually show you in real life what this looks like. So let me do that. Okay. So here, this is on my phone, and this is the desktop thing running. If I type something in here, you'll see there's my rainbow text. And here also rainbow text. Over here, this is slightly different because I just dropped this card just for the layout to make the layout better. This one doesn't have the animation. So if I click it, you'll see it just flashes like that. This one has the animation. So if I click it, you'll see a slow transition coming through. And the same on the phone. If I click here, the bunny's going to appear. Bunny appears. And you can see the confetti modifier in the back. And we've got a color change going on the button over there. And here, same thing. Bunny appears, confetti appears, and button color changes. Click, 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 click. And the last one is this card. If I tap it, I'll get a bigger description. And you can see how it's animating the size. And in this case, also animating the size. Looking at the code of these two pieces side by side, I literally copy and pasted it over. I mean, I can write it in the library as well. But the only thing that was different was how these images were pulled in. On the Android side, I was pulling them in with from the resources with an r.drawable.image name. And over here, I was loading a PNG or a JPEG for these images. And the rest of the code was the same. Okay, let's go back to the slides for a moment. I think I'm probably at the end of where I needed to be. So there's the demo. And just quickly, my impressions. I like the fact that it's declarative. I like the fact that it's really easy to add animations to either the desktop or the Android apps. I like the fact that the defaults are easy and that the common cases are easy to do. So it's really a small amount of code that you've got to add. But then if you do want to change the length of the animation or what the animation looks like, there are lots of powerful APIs to change those animation capabilities. And with that, I think it's time for questions, but also this is the link to my GitLab profile. And there are two repos there. There's Testy Testy, which is the desktop one, and there's Hello Compose, which is the mobile one. And they, at the moment, I just pushed the code up and they have all of the animation examples in them. And that's it. Now I'll take questions.
I hope my mic works now. Doesn't it?
I can hear you.
Okay.
It's still sort of slightly hissy, but I can hear you.
I've got an old Windows machine that I'm going to have to use for presentations, because the audio on Linux just goes nuts when there's more than one thing. Maybe we'll just do this. Is that better? No.
Yeah, that's a bit better.
Is that better? Okay, so I think let's get everybody else on board, and let's see what questions we have. So I mean, a comment I would add. It might seem like some magic is happening, but basically the fact that there's an annotation means that there's an annotation processor that will take that function and wrap it with understanding. And it basically, when it's called the first time, it uses all of those to build up this tree that represents everything that needs to be composed. And it also, as you create the elements that manage state, they get added to the tree. And then when those state events come through, it knows what to recompose. So it's not really magic. It's just represented in a way that's easy to do. Because if you had to write all of that by hand, then you're back in 30 years ago when I was doing Windows programs in C, and you had to write a lot of code to get simple things done, and to redraw only a portion of a screen and things like that. And that's what Compose does. It makes a lot of that easy, and obviously you need some understanding of what's happening so that you don't understand, so that you don't expect the thing to do stuff that it can't. So it's important to have some understanding of what it can and can't do. There's a question, have you used it in production? No, I haven't. I think, I mean, Maya, have you got some Jetpack Compose stuff in production?
No, we're working on it. I just wanted to say one thing, that at Composable, it's actually a compiler plugin. So it doesn't even run an annotation processor. It's actually a plugin that sits on the compiler, and that's why you need a specific compiler version to do the library. So I think I'm going to
Yeah,
hand
but
over to
it's a
Pam, right?
compile-time annotation. It's not a runtime annotation.
Yes, compile time.
Yeah.
So I'm going to hand over to Pamela because she knows about Compose in production.
Yes.
Ah.
So I work at GoDaddy Studio. We create like a graphic design app, and we are using Jetpack Compose in production. We have this cool. We started out by just changing our debug screen to Compose, and then we went over to changing our color picker to Compose, and we're kind of slowly but surely, as we touch different screens, we're converting them to Compose. And Rebecca, who's one of our engineers, Rebecca Franks, she has made this color picker in Jetpack Compose, and she's also ported it to desktop, and you can see it on our GoDaddy open source library archive. And yeah, people can submit PRs and requests and all kinds of things like that. So it's working really well. And what I think is nice is that there's so many things that you can do just so much easier. Like Maya was showing animations that used to be so hard. You used to have to use like the full motion layout. It was like XML and stuff. For other animations, you really had to know your stuff, and you really had to know Android very well. But now it's pretty much, it's really taken care of for you in a sense, in that, they know there are certain kind of animations that you will want to have to do. And a few months ago, there was this Android Dev Challenge. It was quite a while ago, and people came up with such amazing like animations. I've recently seen like a clock of clocks, where it's like every little sort of pixel of the clock is also a clock, and it's like a little ASCII clock thing. The people would just think up these amazing animations and amazing things, and it just works with Jetpack Compose, and it looks fantastic. So I think the ability to create really nice looking smooth graphics that delight your users is what is really like a killer part of the killer app thing for me. Are there any other questions? Come on, guys.
You let Rory in.
Yeah.
Hello. I have a question. So this obviously is very similar to the new age PWA apps that we have. Is this at all cacheable into the browser, and can you run it offline? So can I actually create a kind of a Windows view of it? So you've got your web, you've got your thick client. Can I take a cached version of it and run it in my sandbox?
Well, yes. Look, if you use the Compose for web, then you'll just have to add the service worker and PWA manifest and stuff, and then you'll have the all those offline things. So there, it's up to, because basically that targets Kotlin JS at the moment, and there's quite a few of the libraries that have Kotlin JS wrappers. And it's relatively easy to make JS calls directly from Kotlin JS. So that wouldn't be a difficult thing to do. You just need the wrappers for the APIs. So yep.
Second question. Okay, so given that this is very GPU intensive, what I've noticed there's a lot of controls there. What kind of services are we allowed to use with it that take advantage of some of the underlying GPU processes? Are there any controls that are specific to that, or are all of them assumed to be generic CPU processes?
Oh, okay. So at the guts, remember, it's using Skia as its graphics engine, and Skia targets basically it targets OpenGL, but they on Windows they add the library called Angle, which gives you a translation to DirectX, and they have a Metal version for Mac OS and iOS, and then obviously on Linux it's just OpenGL. And so it's going to do as much as possible to target the GPU. And you must also remember that Skia is what Chrome uses for a lot of its graphics and stuff like that. So the library itself is being exercised in many places, in many scenarios, and it stands up to just about as much as you can throw at it. But it's a
So then-
2D graphics library.
So then it'll probably also be able to take advantage of virtual threads. So you could run multiple instances of it. Because I love the idea of those balls bouncing there. But coming from a child of the 80s, that was the bouncing ball virus, and it slowed down my PC. And I just thought there must be some kind of mechanism to control that, though. So yeah, so whatever Skia can use, then I guess if it's CPU or GPU, then you get access to that.
I've got a little bit of insight into that. I just completed a project for a large bank. And part of it was we needed to do some work for the investment corporation side. So it's basically a tablet app. And on the tablet, they've got a lot of moving graphs and things. So when people are buying or selling Forex or something, they can see what's happening in real time. So we've got traditional Android UI components, but all the graphs are Jetpack Compose components, and we've got about 8 graphs on the tablet. And our initial concern was slowdown because it's GPU, it's all this, nothing. We've got coroutines that sit in the background. As data comes in, it pushes it into the data repository.
No, it's the composer is very efficient. It deals with state, so it literally will only update the stuff that's changing, unless you've done something stupid with the way you've constructed your state. But that's the things you need to understand is how do I design my data structure so that my state is communicated properly, and I'm hoping that what I've done is a reasonable example, because there's, as you can see, there's a state that represents the color of each of those lights on the traffic light and the intersection. And the only reason why those things don't flash at the same time is because I haven't used any of the APIs the animation APIs to do that kind of synchronization. I'm literally just turning these things on and off and changing the color of the little circle that I drew. So it could be even smoother with a little bit of work, but the decision as to what the color must be has already been made, and that's all taken care of. So you can compose your application in layers, and that's what you'll typically do. Is you'll have a core that deals with whatever backend services and state interactions and things like that, and then you'll have a layer that deals with let's say the common composition of the application. And at that level, you will then decide, well, this thing is going to not be a Kotlin common component, but it will be a specific one for each platform. So you will say there's this function that's expected, and then it's provided in each of the libraries and taken care of. And then you can decide, oh yeah, I want to add animation on the web. Maybe I don't want to add the same amount of animation because it might not be applicable. But you've got those choices as to how you deal with that. But it's remarkably powerful, and it's been great fun playing with it. And I've stuck to what was released. I didn't want to dive into the stuff that's still changing and try and build something on that. But when they say it's released, then it's pretty solid. Nothing has been breaking unexpectedly. And I think, I mean, Pamela can tell us if you ran into any weird stuff where, oh no, this thing doesn't work. If you use the versions together as they say, then it just works. And,
So the only comment that I can really make is that we saw things that are very Androidy, like constraint layout, wasn't available on desktop.
yes.
But we didn't really have any like bug reports of this looks terrible and this isn't working. It was all good.
Yes, there's actually, so they if you go look at the actual, so there's a I've shared the links to so there's the GitHub/JetBrains/compose_JB is where all of this is, and there's a lot of tutorial code, and there's a lot of example code. And a lot of the example code actually uses third-party libraries that have been developed to provide some of that bridge between what Jetpack can do and what you may want to do on the desktop to give you common navigation and things like that. And there's the rate at which these things are improving is remarkable. So download it, play with it, try and figure out which version to use, read the documentation, because for a release, there's a specific Kotlin version. Obviously, with the samples, those versions are encoded, so you can take the examples and just try and build and run them, and have fun and share your experiences. But I mean, I've done various levels of UI development over a long period, and this has been the most fun and the easiest by far.
Speaking about fun and easiest, I want to ask if anybody else has had this experience where I'm sitting and I'm doing stuff, and I've got a designer next to me, and the designer's going like, I wonder if we move this around, if we change the color, if we change the font, it was so nice to sit with the designer right next to me and say, okay, let's do this, let's do that, and being able to do this live.
Yes.
Yeah,
and the turnover is so quick.
Yes.
And in fact,
has anybody else had that?
Well, I haven't had the designer next to me, but I could even, whether it was desktop or Android, making the change and seeing the effect is quick. But when you're pairing with somebody, you have the same kind of experience where you try things and this looks. If two people agree that it looks better, then it's a lot better than if it's one colorblind person.
If it's two developers, I don't trust it.
I won't comment on some of the UIs that I've seen or even the stuff that I've inflicted on people. But
it looks like we have another question.
Yes, many clients have asked us whether Compose in production is reliable. Well, Jetpack Compose is very reliable. Desktop is seems to be pretty solid. I haven't heard anything bad. The bottom line is, if JetBrains says it's released, I can tell you the quality is going to be pretty solid. So when they say, so for example, the DOM version is released and you can use it. It's difficult because it doesn't have the same amount of stuff behind it that you have in Android and desktop. So you have to now, as I say, there's a project that's building, that's taking all the material design components, web components project. So this is a web components is a specific spec for designing web components. And the idea is that you can have a visual component that you can hook into any framework. And what they're doing is they now essentially wrapping them with Kotlin Compose so that they can be used. And that project is moving forward at quite a rate, which means that when it's ready, then you'll have a mature set of components you can use on the web, and you'll probably have a good experience. You can make a progressive web app with offline capabilities, and it is it's all in place.
So Smith Kilkenny is saying something else. He says, to be honest, they need to do some marketing about Compose. Many clients I dealt with haven't heard about the tech, so it comes hard to convince them. Yeah.
Well, that's obviously always a part of the problem. I mean, JetBrains has, they are talking about it.
But you're also looking at a broad kind of fallback in the ecosystem, the broader Java ecosystem on thick clients. With the advent of PWAs, people have naturally assumed that the AWT, the swings, the Java FXs, and that entire ecosystem kind of fell away. It hasn't, though. It just hasn't been as vocal as the others.
Yes, actually, and that's so true, because the stuff that's built on Java FX, there's remarkable stuff out there that looks fantastic. And incidentally, if you're doing desktop, you can actually leverage Swing. I don't know if you can leverage Java FX. I was a bit disappointed that I couldn't find that, because that would have made a bit more sense. But there might be some reason for why it's not the case. But you can actually leverage Swing components in desktop. So
yeah, so Swing and Aut, but I think the Java FX is maybe because it's XML stuff. And not
yes,
Java
well,
stuff.
it was part of Java. Now it's a separate open source project that's still going strong.
Yeah, I'm saying maybe the reason why you can't use Java FX stuff and Compose together is because Java FX is XML files and crazy stuff thrown together. And there is a project called Tornado FX, but I'm not really sure.
Tornado FX. I say all that Tornado FX is a DSL, a Kotlin DSL on top of Java FX, so it just makes it easier to develop Java FX apps. But I think that because Skia is your graphics layer, you need these two things to understand each other, and there's probably nothing in place that makes Skia and Java FX understand each other. So it might happen. Who knows?
Hopefully not. It's so much easier to build components in Compose.
Yeah. It's and the reality is it's going to go everywhere, because it's going to be on small devices, embedded. You're going to be able to write code for a watch, because WASM is going everywhere, and Kotlin Native is going everywhere. So if Kotlin Native is there and Skia is there, then Compose will follow in short order, and that's the big driver there is the iOS and macOS, and it's in alpha. You can take it for a spin and see if it works if you're a Mac developer. But I mean, this is a long-term thing. Remember, we know that Google puts stuff out there and then they just take it away, and then we cry about it. But this isn't something that they're going to take away just like that. It's not going to happen with Android. One thing to remember is that there's an OS called Fuchsia. I don't know if that's the correct pronunciation, which was designed specifically to be a new microkernel OS that can be used in mobile devices, but also in tablets and desktops. And Flutter was designed to sit on Fuchsia. And there's nothing that's going to prevent Kotlin from sitting on Fuchsia, which means from Google's perspective, they can move away from the Linux kernel if they want to. They can have this whole ecosystem. And because your investment is at the Compose level and at whatever Kotlin APIs are there, then you can go wherever they are going, and you're not constrained. And because there's actually some technical fundamental issues that prevents Linux from going smaller than a certain size, which means you can't put it on the smallest devices, so you need something else. Now they've got something that's lighter weight and that can go onto smaller things. Because think about it this way: Google Glass was a great idea, but it came out too early, and technically it wasn't where it should be. But in reality, it's probably a good idea, because imagine if you have your glasses with your prescription and you can see information about your surroundings appear literally here, and by pressing on your frame or something in your pocket, you can manipulate the user interface. For me, that will still be a game changer, and I don't want to wear a VR goggles to experience alternate reality. I want my reality to be enriched with information.
You're not invited to the metaverse, okay? So we're all going to be
Please
there.
don't.
Okay, we're all going to keep it clean, and then you're not invited.
That's fine. I've got no interest in that. But if I can augment the reality with more information, that would be great, and that will probably be powered by something like Fuchsia and Compose, putting stuff right here in front of your face.
I want to ask Pamela and Maya something, because I kind of know what kind of developers they are, and I want you to be honest. Okay, so when you started playing with Compose, how much fun was it?
It was lots of fun. I think I started playing around with Compose, I think, when it was COVID, when it just became COVID-y. And I did a presentation on it, and I made this little travel app thing, and it was a lot of fun. It was material design cards, and it was, it was very simple and very basic, but it was a lot of fun. You make a very good point.
Did you just make a joke about Caretti though, of Compose though? That was the most meta joke ever. You said Caretti.
I didn't.
Oh, didn't you? Oh, okay.
No.
There's been so much talk of Compose. Everything starts with a K with me, and I think I've gone a little bit mad.
Yeah.
Oh,
Mai, what do you think?
Well, you can see how much fun I'm having pulling bunnies out from under buttons and making bouncing ball viruses and things, right? So yeah, I'm having fun. I mean, I will see how much fun it is when I do decide to when we do decide to put it in our app, because I think if you've got a bigger app and you need to figure out the themes and you need to figure out design systems and you need to figure out, make sure that everybody's using the state correctly and the navigation and whatnot. So I think then it's going to be a little bit more complex. And there may be days where it's a bit less fun. I'm busy building Compose into an existing open source app as part of my prep for my DevConf talk. And I'm trying to stream it on Twitch at the same time. But I have to say that there are days where it's fun, but it's also like, how do you even do this? So yes, I think in a real app, it might be a little bit less easygoing.
I think one of the important things is that it actually enforces a good pattern, because there's certain logic that you just cannot afford to have in your UI, because it's going to be a mess. So and that's probably where a lot of refactoring is going to have to take place, is to clean up that those UI decisions that were enmeshed with all other kinds of stuff.
Yeah, that's true. I mean, that pattern is a thing, and it's a good thing. It's that immutable state that's flowing through. But developers are very, very creative in the ways that they can mutate patterns to be huge balls of spaghetti, right? So I can imagine someone writing a huge long composable of 1,500 lines where the whole view model comes in the top, and they're just making buttons switching on and off and things flashing this way and that way. You've got your whole screen in one big composable, completely untestable. So it is possible to mutate any good intentioned pattern into spaghetti monster.
But the thing is, it'll be instantly visible by just looking at the code.
But aren't all spaghetti balls instantly visible as being spaghetti
balls? No, I've seen balls of spaghetti that at first glance looks like, oh, this guy knows his patterns. And then when you start tracing it through, you realize, no, he just chose names from the patterns book and then threw stuff together, and they have no bearing on each other, and it's worse. So it's like, it's one big lie. Yeah, now I've seen some terrible stuff. We've got a great question. So decisions about Jetpack Compose falls under the Android team from Google or Kotlin team from JetBrains. Now, I don't have inside information, but what I do know is that they are working closely together on Kotlin Compose. But I believe that what you will find is Jetpack Compose is a superset of Kotlin Compose. So they will always have things in Jetpack Compose that makes Android better. And there are going to be probably more work to provide for what you do at the common level, to have, let's say, a similar abstraction available in the desktop side. So yeah, that's, so there's a joint effort on Compose between Google and Android, and I think, in fact, some of the people who worked on Flutter is involved there as well, because they understand Skia, and we just see the output of that coming through. And if you go and dig and draw a graph of all the names on the contributors and throw it into a graph database, then you'll probably see, oh, here's the Flutter guys, and here's the JetBrains guys, and here are the Android guys, and they're all involved. We've got another nice question. This might be personal, but Flutter and React on the spec, you'll find some helpful video. Yes, so obviously there's it's going to take a while for educational content to come online, but it is. I mean, when React hit the market, there wasn't much either, and people tried to figure it out, and somebody went this way, and other people went this way, and then they got in the same job together, and they couldn't even understand each other's code. So, and you're going to get a similar thing. Depends on what people did before. If they were on an Android project that converted to Compose and maybe did weird things to some of those design patterns, like Maya just said. So education is a big part of it, but the content is going to come through. Part of what we're doing tonight is to try and start this conversation, start the discovery, and have future conversations about it, because I think it's one of the most exciting new things to come online since Kotlin itself.
I can add something about resources. Learning Compose using the Google documentation with those pathways was much easier for me than what I remember learning the XML system. So they've done quite a good job in giving you ways of understanding in simple ways. The official apps that they have open source, the Jet News and Jet Snack and those are really solid apps if you prefer to read code. So those are pretty good. Then also there are some apps as part of the Jetpack code base. You can inspect the code, and they've got a lot of sample apps, and those sample apps have got samples that actually link to the documentation. So there's a really good material catalog app where you can see exactly how all the material components are used, and they're easy to just snip pieces of code out of those apps, and you know that they're really solid. You can also see some good theming stuff there. On the side of that's not officially Google, there are some really nice sites which have if you do it this way in XML, how would you do it in Compose? So you can search things up. If you don't know the wording for a Compose thing, you can type your old XML stuff in, and then you can get the equivalent one. And also open source sites where people are collecting examples, sort of like cookbook style. So those are coming from the community. Then as far as videos are concerned, on YouTube, there's that Philip Lackner guy, and he has some really, really solid information on how to deal with Compose and sort of the theory behind it. A lot of other stuff as well, but he's got some really good stuff on Compose. If you want to watch on Twitch, there's the Code of the Italians, and they get really excellent guests that know about the basics of Compose, that wrote the actual composer, people of that caliber. So if you're more sort of a background Twitch watcher, there's that. If you want to read a book, there's Thomas's book on starting with Compose, and there's Jorge's book on Compose internals. And then I think there's another one, Practical Compose as well.
By Joe
also
Birch.
excellent.
Yeah.
By Joe Birch. Really accessible and easy examples, but not just Hello World style examples. So whether you like watching videos, reading books, listening to Twitch, listening to podcasts, whatever, there's a lot of resource out there actually.
That's also an important point, because it shows you that it's reached the point where it's worth investing the effort and the time in writing books, creating tutorial series and stuff. So now is the time to start adopting this, because it is at the point where people have enough confidence in where this technology has gone to put in 6 months or 8 months or a year to set up a book, for example.
Yeah, so I think what we can take away from this is that because Jetpack Compose is where it started and it's mature, it's a good place to start your learning. And then you need to go through the discovery of, okay, what is now different between Jetpack Compose and Compose Desktop, and what does that mean? Because one of the things that have changed is that Kotlin introduced a part of the standard library is flow and state flow and a shared flow and channels and things like these, which are a way to communicate state to the front end. Whereas with before they came along, you had different mechanisms in Android. I think it was called live data. When I did my first Compose example, I was targeting Android only, and I used that as the mechanism. And then I saw the state flow and shared flow come online, and but the switch over was fairly straightforward. So it is, and I mean, this is the basics of being a programmer. It's an ongoing learning exercise. If you think you learn it once and then you'll know it, don't even bother, because you're going to get some bad surprises. You're going to be left behind. It's a continuous learning process, and that's why we're all here, because we're all, I believe, continuous learners.
Maya's not here to learn; she's here to teach.
Yes, but how does she know what she teaches?
She
She
just
had to learn and had to figure it out. Some people learn at different rates, and so yes, there's a huge amount of information around Jetpack Compose that will give you a solid basis to work. You download Android Studio and you go for it, and all the tools are there and it's documented and you've got no obstacles. And once you're comfortable with that, then you can start going multi-platform and looking at desktop and the others. So yes, there's a whole wide world out there. Do we have any more questions? I think if I can ask Maya, some of those things that you mentioned, would you mind sharing some of the links in the chat?
Okay, I'll tell you what I'll do. I'll collect all of them and I'll make a link where they all are. Then I'll share that link.
Okay.
That's
And then
lovely.
if I'll share it on Twitter. So I'll do a tweet. I'll respond to one of your tweets from the Jersey Jug, and then I'll put like a link to where I've listed all of the resources.
Oh, wonderful. Thank you very much. That'll be great. And yes, so enjoy this journey. I'm enjoying it, and I mean, the bulk of my work is back-end work, but I've always periodically had to do front-end stuff, and I've always enjoyed it because it's a different kind of feedback. It tickles a different part of your brain, and you don't have to imagine that much; you actually have to see it. And the fact that I'm colorblind was my only handicap. But then I learned now you just let other people choose the colors, so we'll make it configurable. I won't tell you about my first Clipper app, but yeah, that's a long time ago. Yeah, so Maya's going to put all those links together, answer to this last question, and share it. I've shared some of my links to the code. Because I think it's a reasonable example of how to put the backend part together, and it's not the best example of how to do the front end layout and things like that, but it's reasonable. It's just the idea was to do a demonstration of what can be done. Any last words from our panel? Rory?
No, nothing much. I have really enjoyed this dabble into you creative types. Us backend developers are very appreciative of everything you do and all the way you dress and talk. So carry on the good work.
Yeah, well,
I'm sad to say that for the next year or two, I won't be doing any Compose. So this might have been my last foray into the Compose world. I will still try to attend and feel very, very jealous of everybody that gets to work on it. But it was very interesting, and I'm glad to see that more and more people are picking up this really cool technology. I'm very curious to see where it's going to go, especially in the embedded space, because I think there's a lot of potential there for really cool IoT devices. But you know, let's see what the future holds.
Maya.
Yeah, so two things. First, thank you very much for letting me talk to you and show my stuff to you. And the other thing that's just a little snippet of information that's really quite interesting is that whole tree and the composer, it actually has nothing to do with UI. The UI is just hooked onto it. So some people have done some really interesting things. So if you have a problem that is tree-like in nature, then you could still use the underlying Compose libraries, even if it's not a UI thing. So that's just a little tidbit of something.
Yeah, I mean, imagine you have a tree and you want to send out notifications based on what's happening. Yeah. And Pamela.
Yeah, me. So I'm gonna, because she's shy, I'll probably have to punt Maya's DevConf talk coming up in, I think, March and April. She's going to be speaking about Jetpack Compose. She'll be in Cape Town and virtual and Joburg, so catch her there. And she also helps along with GDG Cape Town, so sometimes she speaks there. And she also has a Twitch stream. It's called Kibith Codes, where she prepares for her talks, and she just does awesome Compose stuff. So check her out. Yeah, and I've enjoyed being here. Thank you.
Well, thank you everybody for joining us, and I enjoyed our evening quite a lot, and I hope we'll put something together like this in a let's say when iOS is released, iOS and macOS versions, then maybe we can get drag Peter John in here. I tried to get hold of him, but he was bird watching. So in the Kruger Park, not on the beach, and that's his thing. But I've got a hunch that he will be interested in Compose, or we'll find somebody else who's in that game. Maybe even somebody from JetBrains. But let's build out the picture and maybe show a bit more. Maybe some embedded stuff is online then, and but that's not all that Josie Jug is about. For those of you who don't know, so the J used to be for the Java users group, but then we decided it's the JVM users group, and then some time ago, we sort of merged the Kotlin users group into it, and we decided we will be speaking about Kotlin every few months as well. So we cover everything that touches the JVM and adjacent to it. Apart from Node, we avoid Node completely. So. So thank you all. Have a nice evening and stay safe and stay healthy. And hopefully we can share some pizza someday.
Awesome.
whenever that may be.
Thank you, peeps.
And I have to say this, but my heart goes out to the people of Ukraine. I don't know about you, but I'm thinking of them. I don't actually have any friends there, but I've got friends who live in neighboring countries and who's gone
I
through
got
some of that
friends
in the
in
past.
country.
And it's unthinkable. And I hope they find a way to end this. I've got some ideas, but I won't share them publicly. So thank you for joining us. It was wonderful. And enjoy the rest of your evening.
Ciao.
Bye.
Bye-bye.